So I will share my screen. Let me know if everyone is able to view my presentation. Is it clear? Okay, perfect. Yeah, hi everyone. I'm Sushant. I'm the author of SochDB. Thanks for joining today. So let's. I would like to present SochDB today. Exactly, like I'll give you some context, like what is SochDB, how you can use in your regular Agentic and like RAG projects. So that way, so this particular session will help you out to get started. So what is SochDB? So SochDB is like a LLM native embedded database. So it is like a standalone database. It means like you might be using ChromaDB and LanceDB and like different DBs, right? So it's similar, but more advanced than compared to those databases. For example, like if you look at MongoDB is for JSON, right? Like so the way how I projected is like SochDB for AI because mostly like every provider of this DB, they're only targeting vector, but apart from vector, we can do more. So that's the goal of this like SochDB to make sure to give you more advanced features so that way you don't need to juggle with multiple databases. That's the goal of the SochDB. So the next thing, like, so you might be working on a agent project or like a RAG project. So the biggest challenge you face is like, then you started architecting the code, right? Like it's the way how it is. Hey, I want vector databases. Generally, like you go to some vector databases like Quadrant, LanceDB, ChromaDB, and like different. Now I want a KV store. Then you will go for like MongoDB or like different things, right? And if I need SQL, I need a SQL databases like PostgreSQL. And if I need a graph, then you go for Neo4j. If I need a message queue, now I need to use Redis cache. So you will be kind of like juggling with multiple services to get your architecture for this agents and RAG to be working, right? So how do we kind of like reduce that burden? So using SochDB. So that's one of the goal because where engineers can focus mostly on like, hey, designing application with a single database, having all these features instead of like juggling with multiple stuff. That's the another goal. Another thing is like you already know AI is evolving and like the biggest challenge with is AI is memory. You want to keep talking to AI, but it's always whenever you start a new session, it doesn't know anything about you. So what happens is you need to identify some new solutions like mem0, leta, like there are different memory providers like Greta. So what happens, right? It's kind of like you are again like getting into that mode of like identifying the best memory projects so that way you can work together. You can make sure you can make your agentic or like RAG application working as expected. So that's another problem I see. So that's where like you will be juggling with multiple. If you look at from this particular problem statement, right? So the goal is to how we can have a database which can address all these issues instead of juggling with. And another biggest challenge is like how do I save my tokens, right? Like it's instead of like another thing is like you need to write a lot of optimization in your code to make sure like how the token input and token output it's kind of like can be saved to. So that's where like I use something called TOON. So TOON is like another format which will help you out to reduce, but it can support both JSON and TOON. So what is SochDB, right? Like SochDB is a mix of everything. So whatever the problems just now I talked about, right? Like it try to address all those problems with one database. The goal is to make sure like the engineer is only focusing on his work than like going through multiple databases. So it has a support for TOON. It has a support for sync. Like maybe you might be using SQLite, right? Like hey, similarly like SQLite, I should be able to use sync first approach. Yes, it's available. If you need an ACID transaction, yes, it's available. If you want to do a vector search, it's available. If you want to do MCP on top of this database, yes, it's available. If you want to do columnar analysis, it's available. So that's where like you don't need to go outside for look for another database. The goal is to make sure like it's everything is available. So it's stitched together so that way every feature and even the benchmarks are also pretty good. it's very kind of like very competitive and compared to any other solutions you use, right? Like I make sure that like whatever, if you use SochDB, it's giving you the same efficiency, same robust, not same actually. I'm trying to give the best. So that way you're not like getting into like a limbo again, like saying that, hey, because of this particular latency, I have to use another database. No, my goal is to make sure that like you get the best out of SochDB. So even the latency is also talking like even that benchmarks are also talking that like SochDB is doing pretty good. I will show you shortly like what are those benchmarks. So thing like why another database, right? Like as I mentioned just now, just a second. Okay, sorry. Thanks for the feedback. Yeah, I'll slow it down. So the next thing is like when we design, like these are the three concepts which you will be mostly using in your AI journey, AI application like an agent or like a RAG application. One is stateful, search, and the context. What is state? Like you will be having multiple agents running, right? You might be knowing how LangGraph you will be using, like LangGraph, like what it's kind of like it's sharing a state with another state. So what is an output, right? Like another thing is like writing those transactions, like, hey, once that agent is running, I need to record like how that agent is doing. So those kind of like stateful truths you can store. Another thing is recall. Recall is nothing but you search, right? Like the vector databases, you store in embedded fashion and you retrieve. So there are another good thing with SochDB. It has like three different search mechanisms. One is like HSNW, which is like hierarchical network search, right? Where you can use, or you can do a text search, or it's a combination of both, hybrid. So what I did is like even hybrid is also available through this particular source DB, so that way you can do hybrid search, like text and vector, both. Next is the context. So the another biggest challenge where like all this AI engineers face is more on the context side, right? Like, hey, I have a specific question while retrieving certain stuff. Like, how do I get that thing, right? Like, if for this particular session, for this particular thing, I want to have an output. So you can still you can use SochDB for that. Like SochDB will give you that context querying engine where you can have where you can query the specific topic. So this is the high level architecture, like how it looks. There is another diagram which I will show you. Yeah. So the way how this architecture looks, right? So this is your AI application. Think that you have an AI application, and these are your clients, different clients. So good thing is that SochDB supports 4 different languages currently: the Rust, Golang, Python, Node.js. So you can use a client for this thing. So that way you don't need to learn a different language. So you can use your own language if you're like Python or like Node.js or something, because these are two very popular programming languages. So SochDB has support for that. And SochDB has support for the MCP too. And SochDB works in two things. One is FFI, and another one is like the gRPC. So FFI will help you to not to have like a connection string where you can directly work on it and like get started. Whereas gRPC, suppose you are hosting somewhere in the cloud and you need to connect to a SochDB, it has like gRPC connection where you have to just give the gRPC host name, so that way you can get started. So this is how the query processing happens. So I know the another biggest challenge where engineers face is like learning multiple languages. How to reduce that friction, right? How what I did is like I added SQL support, so that way if you are good at SQL, you can use SQL to interact with SourceDB. So that way you don't need to work on no, you don't need to learn another new language to get things done. So the goal of this thing is to make sure like you can just run raw SQLs. So I added that layer, so that way you can just run that SQL to get that answers, instead of like you learn another different language or like APIs to get things done. So it exactly works like how your SQL databases works, like insert, create, and another thing is like the querying, right? Using select, how you pull the data. Similarly, you should be able to pull everything. So this is the brain. So this is like an internal core of like how SochDB system works. So where it has like a kernel and a core. So that way what happens based on your request, it automatically kernel will take care like what kind of things I need to do based on your query. Like if you look at the bottom, there are two, right? One is like the storage engine, another one is the index engine. So that kernel will take care of like how to index it and how to storage behind the scenes. And then your disk, like how it gets stores on your disk. Okay, I will switch back to the presentation. So that's what this particular slide is talking, like how we have a different layers, like how each layer is working towards, right, in that particular fashion. So let's compare the thing like when you look at these are the things which you look because these are the most interacted databases if you look at in the world, right? Like, hey, if I want to do some lightweight transactions, like which database do I use? Like immediately everyone uses SQLite. Hey, I want to use some vector storage. That's where like you want Chroma or Python. No, I want high throughput of inserts. Then the people uses high throughput of inserts with vector. Then they use LanceDB. If you look at their futures, right? Like if you look at embedded server, everyone provides, but Pinecone is like more like a cloud provider. So I will avoid most of the time. But the Chroma and Lance are the similar window. If you look at from the ACID transaction where SQLite provides, but Chroma and Lance, they never provide any ACID transactions like for you. Another thing is like vector search. Vector search is available on the Chroma, but not available on SQLite. Again, you have to add additional plugin if you need vector search. So again, the next thing is like you need to work with Chroma and Python and LanceDB. They have that search because it's a vector database, right? So they give you API to search that database. Second thing is like SQL query support. If you look at SQL query support, it's only available in SourceDB, SQLite, and LanceDB, whereas like other DBs doesn't have it. And another thing is like, as you know, storing a normal transaction may not give you the exact memory what you are expecting. So we need more than, right? Like, because even nowadays, every paper is talking like graph is better for memory because the way how the data is getting stored in the database, right? Like in a graph structure. So it uses similar graph traversal with a BFS, like Beth first search. Like how do I, if you ask a question, like how do that particular node or like getting queried, right? Once you create that graph, so how you can query. So those kind of mechanism is already available. So this is something which is no one is able to provide that. Like I'm providing you for that. Another thing is like MCP protocol, which is by default coming. Most of the providers, what you have to do is like you have to write down on top of that. So here with SourceDB, the MCP protocol is also available by default. So that way you can directly connect to any of your MCP client and start talking to the database. The next is like LLM memory schema. So that's where like mem0 letter are providing an API on top of vector databases. Suppose like if you want to use mem0, for sure you need Chroma, Pinecone, or LanceDB. On top of it, you can have the mem0. You cannot directly work with mem0. So that's the thing actually. Why you need an additional wrapper on top of a vector database, right? Like so, we need to have that functionality within the database itself. So that's where like there is something called LLM memory schema that will help you out to address that problem too. So that way you don't need to have an additional wrapper to get things done. Token optimization. So this is something like, as I mentioned, you like this particular source DB supports 3 different formats when responding back to you. So because if LLM wants to do querying to the databases, what happens? It gives you that raw JSON or like a raw column IO table structure, or like it gives you more like a TOON format. So if you take another languages, you have to write down that wrapper on top of that. So to reduce the friction for the engineers, what I did is like, hey, I added that token optimization on the top itself. So that way, what happens? Hey, I want the TOON format to reduce my token consumption. So automatically that response will be converted into TOON for you. So you don't need to add another thing. That's the good thing. Another thing is like it's SIM ID, SIMmed acceleration. What it means, like it's a single input, multiple data. It means like it's a multi-column database. So that way you can give a single input and a multi-column thing for the vector where it can get that multiple object at the same time. So it has that same integrated in it. So as I mentioned, like this is how the TOON format versus the JSON format looks like. If you want to reduce the cost, because you give access this database to LLM and like use the TOON format, so that way automatically it will save you that commas and like the spaces and stuff, right? So that way you can save tokens. So where you can use the SochDB. So you can use all the 6 use cases. You can use like an AI agent memory or like LLM tool backend, or you can use your edge computing today. Like if you have Raspberry Pi or like if you have any edge related devices, right? You can use it. And the rack pipelines. We have a rack pipeline. Like if we want to use SourceDB, it's available, and knowledge graph. So within the rack pipeline itself, I want to store it as a, like a graph structure. You can store them and you can retrieve. And another thing is like the way how I did it, like if you want an observability on top of this agents, because agents does a lot of interactions and you need to store that information and retrieve for your own analysis. Even it can give you that flexibility of observability and logging of those agents so that way you can do everything. So these are the different things you can do with SourceDB compared to another providers. So when you look at the simplification, right, when you start architecting your agents like RAG or something, if you look at on the left side, this is how your typical architecture looks. You will have your agent. You will have like a PostgreSQL for your users and settings. Then you'll have a embeddings, which and such in the vector databases. Then you will use like, hey, I want to immediately retrieve certain cache and stuff, right? Like then you use Redis. Hey, I want my agent memory. Then you will be using mem0 and leta and stuff, right? Like if you look at it as an engineer, you are like almost like learning multiple languages to get things done. But when you use SourceDB, it's just a single databases which gives you all these features with one thing. So that way, what happens? The complexity is less. If you know SQL, you don't need to learn anything new. All you have to just work with SQL to get things done. And your complex, if you look at the code size, right? Like even that code lines also will get reduced. So let's deep dive into agent memory. Like what are the things this agent will able to provide, right? Like if you look at today fragmentation, you need vector database. So if you want to develop any AI agent memory, first thing is like you need vector. So all the data you store in a database should be vector. So that's where like you use Pinecone or like Quadrant or different databases to store in a vector embeddings. And then you need the session cache. So that way what happens, you can get that session related data much faster. And you need a structured data. So if you need a structured data, like then you need to store it in PostgreSQL, you need a memory layer, then you get it. And then you need a event. So because agents will be able to work on more on events. So suppose like if you have an event driven agent, again, you need to use Kafka. Even how do I reduce that, right? So if you look at SourceDB has given this almost like 6 APIs. One is like the vector search, which HSNW plus SIM. And another thing is like KV store. KV store is something like key value store, like how you store like in a JSON, right? In the similar format. Next is like more SQL support. So that way you can do select, insert and update. Next is like the graph, the temporal graph, like the way how you want to store more like a dated fashion. You can store them in a graph. And I added queue mechanism. So that way change only data sets log trailing, right? It automatically does that queue as soon as any change happens, like hey, trigger this particular event. So even that queue mechanism is available through SourceDB. Another thing is like from it comes to memory. So these are like the top layers, right? One is episodic memory, entity, events. So even you can store those things. So that way, as soon as you call that memory layer, it will give you that right answer. So why ACID matters? The next thing is like it's ACID, right? Like ACID databases, right? Like how SQL works today with an ACID thing. SQLite is the best example. So why can't we have similar experience for the databases, right? So that way I brought SochDB with ACID transactions. So that way your data is stored more atomic, consistent, and reliable. So that way you can get that data even when the crash or anything happens, you will get that proper recovery and like it's able to retrieve that data much faster. So that's the goal. Next is like system level optimization. This is more in depth. I will skip this slide. Yeah. So the thing is like how everyone is solving, right? When it comes to APIs, this is where like you will see how Chroma plus PG vector. PG vector will be like another vector databases, but it's kind of like you have a PostgreSQL and you have like PG vector also, like it will help you to save that data. So in the vector embedding, so that's where like SourceDB is trying to give you that hybrid search along with the ACID transaction. So you don't need to have PostgreSQL and Chroma. Whereas like Redis and Mem0, right? Like for the agent memory, that's where you have like same episodic event schema and stuff. So it automatically defined for it. So that way you, as soon as you store and you use that API, it will automatically capture those events. Next is Pinecone for production vector, right? Like that's where if you use SourceDB, you will save that $70 per month for the minimum. But SourceDB is unlimited, you can use it. Another thing is like recently, like how OpenClaw developed their backend, right? Like SQLite and LanceDB. If you look at it, SourceDB will address this thing. So you don't need to have like SQLite and LanceDB. You can use the SourceDB itself. So it can replace that two services with SourceDB. So let's look at how a developer experience looks like. When you use KV store, right? It's simple. You just need to have a database open and then put that key and value. And how do you query back? It's the same. Select star from that. You can get that value, or you can search that through vector database. Like if you look at 4 simple APIs where you can get started with SourceDB. So let's show you some demos. Before I jump onto demos, any questions? Cool. Okay, let's see how each example works so that way you are aware how in a code side, like how it works, right? So I think Kaja will share you in after this session, this notebooks so that way you can play around. I'm using Gemini key, which is like free, where you can go and create your own key. So that way it comes for free. So I'm using two models. One is like Gemini 3 Flash Preview, and another one is like embedding for the embeddings. So both are free. You can get it. This is the client, which is helping us to talk to the Gemini. Second, like how do we get started, right? Like first thing is like you need to install SourceDB. SourceDB is available, as I mentioned, it's available through multiple packages where you can uh, go PyPy and like search, you will get it. If you go and type SourceDB, you should be able to identify SourceDB there. So this is where like you do pip install SourceDB if you are looking for Python. No, I want Node.js. Even Node.js is also available where you can go on Node.js. So even SourceDB Node.js is available. All you have to do like npm install at SourceDB. So the SourceDB package will get installed. The next thing is like if you want to have like Golang, Golang is also available. For that, you need to go to the Golang package. You go to repository. If you go to Go, Go is available here. So you can get Go also. All you have to do just go get this one. So it will install that package for you. For Rust, we have something called crates. You can go to crates, and if you search SochDB, even crates are also available where you will be seeing that information here. So for 4 different languages, it's available. Java and like other languages are like in the pipeline. So you should be able to see in a short time, like even we have that SDKs available for C# and Java. Yeah, so what I did is like I installed SochDB. If you look at the SochDB package is got installed. So this notebook already has that information. As soon as you run, that package will get installed along with it. So SochDB, OpenAI, Python. So that's where like you will be seeing this thing. Next thing is like, how do I get started? First thing is like, any databases, right? First you need to, because as it's like embedded databases. So what you have to do is like, first you need to create a path where you want to store this data. As soon as you create this path, if you look at this particular folder will create and it will have a wall. So wall will help you out to create that ACID transaction. So that way, even in crashing, it automatically able to retrieve that information for you. So it has that wall mechanism. Another good thing is like it has namespace. So that way you can isolate the information. Suppose like it's almost like a database concept where you create a database and then you store the tables, right? Similarly, it has like namespace isolation. So that way you can store uh, this particular HR related database data and only this particular namespace. Now I want to store all the sales related in the other namespace you can store, so that way they are all separate, or you can namespace by your agent names actually. Hey, agent A will be stored, information will be stored in this one. Agent B information will be stored in other one, right? So that way you can store information in a more namespaced fashion, so that way they are not mixing up together. So once you have that namespace is created, the next thing is like you need to do write a configuration, like what you want to exactly, how do you want to store this information, right? Like if you look at this is like a company policy for, because I'm just took an HR use case. I want to store all the company policies. Next is like the dimensions, your vector dimensions. There are different types. If you take like local ones, which are like starts with 382, but I would prefer at least to go for 1500 dimension. 1500 dimensions are mostly available with big embedding models. So right now I'm using 3072. 3072 is provided by the Gemini embeddings. Next is like the cosine similarity. So there are different types of algorithm. Here I'm using the cosine similarity. Next is like hybrid search enable true. So I was talking about, right, you can search with text or you can search with embedding both together. So that's the reason I said hybrid search is equal to true. The next is like the context field is equal to text. The information which I'm storing is more like a text like fashion, right? Like so that way you can search that information too in a text fashion. Now what we do is like we create that object called collection. Once we have collection, now we need to prepare a text. So this is the text where you will be having. So I created only 2 policies for now. All employees get exactly 20 days for the paid time off for the starting January 1st. The second thing is like the company strictly uses SochDB internally for all the AI and vector searches. So these are the 2 information which I want to store now. If you look at it, this is how I take the embeddings and this is how I store the information and the information is stored. Now let's retrieve that information. So at a step 4, I'm trying to retrieve that information, what it got stored in the SochDB. If you look at it, there is a user query. I'm a new employee here, like how much PTO do I get? So now what it does, it's kind of like it takes that query and like gets into that embedding search and get you the relevant data, right? Like this is how you build the search hybrid search. And like the text is just to search with PTO. And the vector is like, this is the vector we pass along with it. So that way it does both hybrid search. So to balance that hybrid search, right? So that's where we are balancing 50% text and 50% vector. So that way it can pull anything in between. So now you have all the information. Now just let's run the LLM to retrieve the right information for you. If you look at for your question, all the output you get is like all employees get exactly 20 days of paid time off. So it's able to pull the right information. So we stored two informations here, but it's able to pull the right based on your question you asked. So that's the RAG. Now let's look at the SAG. What is SAG? SAG is something like a cache augmented generation. So the thing is like to reduce because the thing is like this is the optimization technique we use to ensure that if a person is asking same question and again, instead of taking that question to LLM, what we do is like we cache that responses. So that way, as soon as you ask the same question, it will get from cache instead of getting from the RAG, from your LLM and the RAG. So that way you can reduce some the tokens cost here. So that's the technique everyone follows. So you can do cache tag also. So how it works, it's a similar. First, you need to create your LLM client for the embedders and the LLM both. I have installed the same SochDB here. First you have to create a database open. So that way it will automatically knows, okay, I need to store the information. Once the information is stored, next is like, hey, ask LLM with a cache question, right? Like, hey, before addressing, like if you look at all the logic is here. First is like, is your question is already part of a cache or it's a part of the database? That's where it takes that particular logical decision. So that way, as soon as you ask a question, it knows exactly where to hit. Like, do I hit to cache or do I hit to the user? As I've asked it these questions earlier, so it clearly tells that, hey, hit to the cache to get the response. If you're not hitting a cache, it tell you like exactly like I'm not hitting a cache to get a response for you. So that's the logic of SAG. Next is your agentic memory. So agentic memory, let's take another example for this. Yeah, more conversational. So think that you are doing more conversation because this is how the chatbot works, right? So your chatbot is more like giving chat experience. Like, hey, I ask a question. Suppose you are in a chat GPT and you're asking questions like left and right, like you had like 50 different questions. Now, within that transaction, right? Within the transaction of that request or response, what happens like you will be asking a question which you feel like LLM knows it and it should be able to retrieve that relevant data. So that's where we need to have that persistent conversational memory so that way it has that multi-turn concept. So how do we implement that multi-turn concept, right? So this is how you implement. You have SochDB, the same thing. So you'll have that embeddings. Next is the initialization of the database and the collections. So as I'm storing the information in multiple levels, right? If you see like the knowledge and memory, so there are two different collections. So I just wanted to make sure like the knowledge is going to the knowledge collection and like I'm storing the memory means memory collections are going to the memory direction. So that's where like you have a different parallel stuff. So that way you can store the information that. Next is like, if you look at, this is the knowledge base, which I want to store in my knowledge collection. So if you look at it, this particular data set will be ported to the knowledge collection. This is the LLM based extraction. Suppose now if you ask a question now, like, hey, if on that collection, should I be able to retrieve the information or not? So this is how the code is all about talks. It's able to get that. And the next is like building up the memory. So during the conversation in the chat, like I should be able to hit that cache and like able to get that answer again, like instead of like going back to the data knowledge. So this is how the first turn is like you just ask a question and you get a response. So cache is missed. So it's kind of like it no need to hit a cache like, hey, what is this SochDB and what it makes special? So it's able to went to the knowledge and it's able to retrieve. When it comes to the turn two, you ask the second question for the chat, like, hey, I'm building an AI application called Smart Search that uses SochDB for the vector storage. And the project is written in Python and you use RAG for the answer. So this is also like the new question, actually. It's not a new old question. So that's where it misses. Second is like test memory, whether it's able to recall like the previous question I asked or not. So what project I'm building? So what is the stack? So this is where like it has to tell that you are using SochDB. So if you look at here, it's able to tell that the technology stack for the smart search you included like Python and stuff. In the beginning of the question, like he asked like multiple questions, right? So now in the third turn, I'm asking the same question, like what stack I'm using. So that's where like it's able to know that, hey, you are using Python and SochDB for your thing. Third thing is like, hey, now I ask the same question now, like, hey, tell me about SourceDB and make it unique. So it's similar question. I don't want need to go to the RAG to understand my knowledge base to get an answer. So this is where it's trying to hit a cache and get a response back to you. So inspect consolidated memory. So there are like different types of approaches where I'm just giving you. So this is how the conversational history gets storing because I'm doing a chat conversation between the what we call between the SourceDB has a backend and like having a chat interface. So now I'm trying to chat between say like and how that conversational history getting saved. Like if you look at it, I asked that first question in the top right, like, hey, what is the SourceDB? What it makes special? So the assistant response. What is the I'm building something right? Like so it's kind of like it gives it. It's kind of like storing the transaction. That's the thing which I want to show you here. Any questions, still? Okay, so we keep going. Let me explain you more advanced topics of RAG. So there are multiple types of RAGs, right? Like, hey, the chunking strategy and like the hybrid retrieval, metadata filtering, brute force search, search request, Gemini powered RAG. So there are different types of approaches. Let's see like how SochDB is helping you to help this. SochDB is helping you to have this advanced RAG. Similar, first what you will do is like you will set up your databases. So that's where you will see the database is getting created with dim. So dim is nothing but your dimension, like how do you store the information in the vector databases. It's 3072. Now you need to ingest the information. So this is the information which I'm just ingesting into the SourceDB. So this is where your chunking and other stuff happens, right? Like that's where you store the information. And next is like the basic vector search and extract the information. Now, like, hey, what is the transfer model? So I've stored the information, right? So based on that, I'm trying to ask that question now. So now SourceDB is helping you to get that search and like get the responses. Like these are the scores it will give you. So this particular machine learning keyword is the highest match. So this is how the document one, which is like more ANN search. This is more brute force search, but both are giving you the same response score. So based on the score, you will retrieve that particular text and display it to the user. So the next is like multi-vector document chunking, where if you have like three different chapters and like you want to store. So the thing is like in a book, when you look at the page, there are multiple paragraphs, right? So when you store that information, like how do you store that information, each paragraph? But the problem is, as there is a sizing problem, right? You cannot store all these pages, a single page in it, right? Like, so what you have to do is like you need to split that page in a way it's more contextual information instead of like, hey, I want to write like there are 6 paragraphs. Within that 6 paragraph, two paragraphs are well connected. The third paragraph is not well connected. So when you do the chunking strategy, what happens? If you take first 2 paragraph and like, hey, still it can fit. So what you can do, you will take the third one also and from the off of that particular text. So what happens with that is like you are like unrelevant data is getting into the vector, and when you try to search, it will give you not relevant answers. So how do we make sure like it's getting that best chunking strategy, storing that information? So this particular one, which will help you out like the multi-vector document, like how do you store each chapter separately so that way you can get better answers. So the next is like the metadata filtered search. Like so right now we created a metadata, right? Along with like this is the metadata. So based on that metadata, like I want to have like 2007, like on this particular story, I need to pull the information, right? So you can ask that related metadata related indexing questions. So that's where, like, if you see, there are three different questions being asked, and this is the filters applied, right? Like, hey, I want to apply a filter for like the year based, or like I want to apply based on the category, or like I want to apply filtered on certain criteria, right? Like if you see, all this scores will be displayed. So based on your question, that is the score you will get. Based on that, you will be should be able to retrieve. So the next is like the hybrid retrieval. Just now I was talking, right? Like you have like hybrid retrieval, like whether you can do text and embedding both together. So this particular example will help you out to address that. Similar, yeah, there are more examples like in the similar fashion. Once you run, like you'll get to know more actually. Cool. Yep. Any questions? Cool. Okay, now I will show you like how the benchmarks, right? Because when we do something, we need to understand like, hey, how the benchmarks are important to ensure that I'm using a right database for like all my use cases. So if you look at it, like I performed the benchmarks to ensure that you are getting, you're taking the right decision while using the source database, SochDB. So if you look at, I performed against ChromaDB, which is like more similar to SochDB, but it has more advanced feature compared to ChromaDB. And there is a Quadrant. Quadrant is the toppest in the vector databases where they are the ones are top. So I did a market comparison on this benchmark. So the benchmarks, I want to make sure like I'm doing the right judge that like I'm taking the right decision that the right database is getting used here. So if you look at, these are the different types of factors which I used. This is the vector DB benchmark is created by Quadrant. So I'm using the same Quadrant benchmarks. Like if you look at Q Quadrant is the one who created this particular framework to understand like which vector databases are performing what, right? So I took the same steps. So based on that, like if you took it, this is for 100K vectors, and this is the response. So if you took it, this is like 384 dimensions. It's almost like 1 million vectors. There's another one, which is like wiki pages, like how you have your wiki pages, right? I use the same wiki pages to measure the information. So there are different statistics. If you look at it, uh, SourceDB is doing pretty good on all the latencies. Like if you look at the lower is better, Quadrant, Chroma, embedded and SourceDB. If you look at SourceDB, is kind of like it's giving you the lowest millisecond response. The next is like on the titles, right? Like on the most on the vector search. If you look at, this is the latest, this is like 1.5 milliseconds, the latency. If you look at the wiki pages, even the wiki pages also like it's able to pull within like 2.2 milliseconds, whereas others are taking more time. Even the DBpedia OpenAI 100K, right? Like if you look at SourceDB only took 3 milliseconds. So if two different protocols, one is like FFI, another one is GPI. So if you use gRPC, because the thing is like has it as a network connection, right? Like so that adds up more little bit of 1 more millisecond latency. That's the reason you are seeing a little bit more on gRPC when you use. So for the memory comparisons, right? Like, hey, I need to do like how the memory is also doing. The lower is better. If you see like SourceDB is always lower, like how much amount of information is getting stored. Like everyone is taking more memory to store because it has a compression logic. As soon as you store, that compression technique will take care to store in a very minimal size compared to anyone else. So this is more on the throughput. If you look at SochDB, lower left is better. Like if you look at here, this one is doing good, right? Like in that particular angle. So search precision. So search precision, it means like you're getting accurate data. That's where you will do using recall with at 10. So and you will understand like who is giving you the better answer. Like higher is better. If you look at SourceDB is doing pretty good on the searching. Like if you ask a question, it will give you the best answer compared to other providers. So that's how you get to know like you're taking a best decision or not. Even I added more if in case like if you want to learn like, hey, SourceDB, if you go to the page, you should be able to see more information, like how others, like I added more benchmarks. for SochDB and LanceDB, like how the vector search is doing, like what is like who is best on what. So this is the comparison which I put, like where you can go and check like who is doing. So there are different techniques we can apply. So based on the techniques also, what is the ratings you get. So if you look at it, like SochDB has different techniques. Like I use SochDB plus ID, SochDB plus re-rank, SochDB plus advanced and hybrid. So I was testing on all other factors too. It's not just like, hey, I want to, because everyone follows different techniques, right? Like how do I do that? So even that different techniques also you should be able to see. So that's where like you see the scores, like SochDB is doing pretty good compared to anyone else. Even we did memory ones, like if you look at mem0 versus the SochDB, because you need to make sure like while taking even memory decisions for your agents, like I need to get the best out of it, right? If you look at it, SochDB is doing pretty good compared to mem0 because mem0 works on top of their vector databases, right? But the good thing is like SochDB is completely working on the memory, like memory layer is already a part of it. So that way it's giving you most of the best of it actually. So that's it for today's session. So feel free to go to SochDB and you will get more the information. Like it has all the documentation and stuff. Even if you go to a website called SochDB, you go to the documentation, you find like the latest document available. So happy to take some questions.
Yeah, there is a question in the chat, Sushant, and the question is how SochDB is different from Supabase.
So Supabase is more of a think like they did a wrapper on top of PostgreSQL, because the thing is like as an engineer, you need to have an authentication mechanism, right? And another thing is like you need to expose as an API. So SuperDB is kind of like trying to solve that problem.
So
Hope
that
that answers your question.
brings to this question, right? So how does SochDB allow authentication then?
Yeah, I think that is something we are building it right now. So hopefully in the near future, SochDB will give that authentication layer also. So that way you can directly plug in into your, it's mostly useful when you are building like, hey, I want to write a single additional code on top of it. So that's where like this APIs will help you out. Actually, so SuperDB is more like a cloud provider. This SochDB is more like you can control on your own because you can run it today on your laptop. But for SuperDB, you need an API, and another thing is like you will be storing entire data in the cloud. So
But
whereas
you
like
have...
SochDB,
Sorry, go ahead.
yeah, and it has like authentication mechanism. That is something still we haven't added. So in the next release, I think 2.0 is coming up in short period of time. That's where you see the authentication mechanism. So that way, even that data security and everything, the guardrails are built in with it.
Okay. You have mentioned that SochDB can also be installed on cloud, and it's you've mentioned that the mechanism is GRC or gRPC, right?
I think you are
Sorry, you're
breaking
up.
Okay, 1 second. Can you hear me okay now?
Yes.
Okay. You mentioned SochDB can also be installed on cloud.
Yes, you can install on your server, or you can set up as like a cloud environment through gRPC today.
Through gRPC. How is that different from being a cloud database, cloud native database?
So cloud database, suppose you have Azure or any other providers, right? Now you want to deploy as a SochDB. So we have given an option called Docker container. You can build a Docker container and you can deploy. So that way you can get that cloud experience too. So in the future, we are planning to get that cloud too. For now, I think you should be able to so the thing is like I want engineers to taste first. So that's the reason we haven't focused much on the cloud. But in the near future, I think in a month or two, you should be able to see our cloud offering also. So that way you can directly use our gRPC APIs to start communicating and working with it instead of you install. But right now, the current use case is more standalone. Like, hey, I want to have like SQLite, right? Like, hey, instead of using SQLite, I want to do more agentic. With SQLite, agentic is not possible actually. It's more relational, right? If you want to add additional, like more agentic, like vector related, like RAG or anything with SQLite today, you have to do a lot of work. Instead of that, if you directly use SochDB is giving you all those APIs to get started immediately. So you don't need to think much actually. So if I have to answer answer your question for today for your agents, it's more of a local. If you want to build a local chat or something, which is like private running, so that's where the SochDB will help you more like a standalone option.
Okay, and also you've mentioned that we could do columnar analytics, right? And does it mean that it's a columnar database?
Yes, I have given that LSM storage engine behind the scenes, so that way you can store that key value.
Key value is not a columnar database.
No, sorry. The thing is like the LSM structure will store that in columnar. Like you can store in a more one column structure, right? Like how Coach, I think Cassandra and like there are databases, right? Similarly, like how you want to store. But the thing is like I'm not focusing on that particular API, but it gives you at least like key value. But my goal is in the next release to have that feature so that way you can run that analytical engine on top of it, more like a column IO structure on like how you do it on the Cassandra, right?
Mm-hmm. Okay.
Yeah.
Consider me as an OS on the Agentic AI.
Sorry, you're breaking up again.
Okay. Can you hear me okay now? Is that
Yeah.
okay? Can you hear me?
Is it only me, Kaja, or like are you able to hear?
Yeah, it's you're still breaking.
Okay. Please take other questions in between. I'll just try to plug in earphones or try to log in from other device.
Okay. Yeah. So there is another project which we did to prove that like how the analytical engine is working. There is something called Agent Replay, which is completely developed out of SochDB. If you are developing any agents or something, you need an observability, right? So this Agent Replay will help you out, see like how this analytical engine is working in case like if you want to test it out today. So this was developed completely on top of SochDB. So all your observability for your agents can be done locally. And even if you have Cloud Code and if you want to see like what Cloud Code is doing, this particular desktop tool will help you out to track all those transactions too. Cool. Yeah. So I know I can take that questions offline. Please post me to Kaja. So Kaja will post me. So I have another thing to take care.
Okay.
I
One
almost
last
like top of.
question. Are you
Sure.
able to hear me now?
Yes, I can.
Okay. Firstly, thank you for taking us through this informative session on SochDB, and I think I also concur with Naveen that this is going to be a game changer in AI era. Now, I have this basic question: is SochDB going to store all of the interactions of an agent? Is it built purposefully to store the agent interactions, or is it kind of all the activities that an agent does?
So I'm giving you that flexibility with SourceDB. So because database is something like a storage engine, right? Like based
Right.
on like how do you so suppose if you take any SQLite, PostgreSQL or anything, right? Based on the way how you storage, that's how the engineer will try to store the information in that particular fashion, right?
Mm-hmm.
So whereas with SourceDB with a multi-model, I'm giving that flexibility. Hey, I want to store a vector, you have a storage. Now I want to store like a KV, you can store it as a KV. And on top of that, I added an API layer so that way you can get all other services out of that, right? Like in that particular fashion. So it gives you that flexibility so that way you can use it for different use cases actually. Because my thought process here is like, hey, as an engineer, I should not be looking like this particular storage engine is not available. I cannot store that information. Now I need to use a different thing, right? So to address that problem, I'm trying to give that storage flexibility in a different multi-column way. So that way you can use it for different use cases. So it can be for observability, it can be for your RAG, or it can be for your memory, or it can be for your other different, just like a key value store, you can do it actually. So that way, like even if I want to just develop an application on top of it today, you can develop.
Got it. Yep. Thanks for taking me through that, and I'll probably connect with Kaja for further questions. Thank you.
Awesome. Thank you. Thank you, guys. Bye.
Yeah, fantastic. Thanks, Sushant. So this is the first introduction to SochDB that we have. And our team, will be doing more of these sessions. And we would want to do all of these sessions, at least for the first 2 to 3 months, purely online, so that we can have attendees from different regions. And then we'll see, based on the interest of the community, to see how and where we can do in-person meetups. So there are a lot of things that are in the flight. We'll keep you updated. Please keep joining the other sessions. If there is any feedback, feel free to let us know through the comments, or you can even give the reviews on the meetup itself. So there are a lot of things that are in the flight. As I said, we will be creating a lot of content for you. A lot of documentation is being created. There will be ambassador programs soon. We'll be announcing that as well. So, and of course, as Sushant mentioned, we also have built a couple of full-blown products apart from agent replay that Sushant has mentioned. We are also building more on top of SochDB, because SochDB makes you much easier. The AI development makes much easier. Some of you already concurred with that thought process, right? So we will be doing more of these sessions. As I said, please do let us know your feedback and what exactly would you want to see. And if you would like to contribute to SochDB, the open source, right now SochDB is fully open source. The entire information that Sushant has shared is fully available for you to view. And if you wish to contribute to SochDB, please do let us know. We'll be more than happy to probably do one contributor session as well. Sushant, probably we can plan to do that as well sometime in the very near future. And if there is any feature that you would like to see in SochDB, please feel